you happen to see the building, you get an idea. It's just a college basketball arena. So the tests were pretty simple and straightforward. We were trying to address the problem like he was talking about of communications within the first 100 feet or to get into people inside. The public safety people are moving to 700 megahertz. They've got a nationwide band of frequencies now, 700 megahertz LTE. What does it take to get inside the building? We started with an outdoor cell site 2 kilometers away. You only got so much coverage. We put a small cell, 5 watts inside the building. Things got better. We put up a distributed antenna system in the building. That actually was the best. And last but not least, I left it out in order. We put a small cell at 8 watts out in the parking lot. This is a college professor trying to imagine how he does his job. But it's like, okay, the building's on fire or whatever. What was it? Volcano shows up in the building. So we park out in the street, we shine an antenna on the building. Will this work? And it does help. So in that order of preference, the outdoor cell site, not so good. The cell on wheels outside pointing out the building did pretty good, but you didn't get in the basement. We even turned that up to 40 watts trying to get into the basement. The battery life is still poor. You didn't get very good performance, but you got better. The cell site inside the building, just one single cell site at 5 watts, helped a lot. But the best was DAS, distributing 23 dBm to 4 locations in that building, got into the basement, got everywhere else. And in other words, the message here is bigger than public safety in some ways. There is a business case to be made for performance and coverage inside buildings. In other words, the money and time and trouble that we're spending to put little cells around buildings is actually a good thing and paying for itself. All right.
Thank you. Yeah, there's a white paper right on your website about that research if anybody wants more information.
The publication part, the measurements were done 2 years ago. We wrote a couple of big reports, but the final NTIA report just came out this last summer, and it's free for the publishing or free for the downloading off of the website. I can give you the information there. I don't have it memorized. Okay.
I mean, and this is actually an interesting point where I think public safety can actually ride on, we'll call it commercial viability. I mean, today, everything you just mentioned, remove life or limb discussion, these discussions are going on every day on a commercial level of how to get better coverage inside of a building just for cell phone data usage, et cetera. And there is a tremendous amount of work there. These type of analytics are going on every day, going in. The hope that I think everyone wants is here you have a very large market, a juggernaut, chugging along, doing these type of calculations. Public safety in that world literally just looks like another carrier. It looks like a Verizon, it looks like an AT&T brought into it. So yes, keep touting that because we want more DAS put into environments. We want more of this being put into areas, and we think public safety can actually benefit from this.
Well, that's what this conference is all about, is a densification of the network in HetNets. And in the public safety space, they certainly stand to benefit. And I just need to point out one of the fallacies here. Yes, at 700 megahertz, they look like another carrier on the 700 megahertz band, and life will be really good. We have to make it robust so that it lasts for 2 hours in a fire and 12 hours up and things like that. But the trouble is, if public safety is not on that DAS, when they're on a different band, this problem goes away. But if they're trying to communicate at 700 megahertz and they're not on that DAS, then AT&T and Verizon and everybody else, just to call out the names, are going to be jammers, and he's trying to get back to a cell site down the road. It ain't going to work. So there's a lot of problems to be solved here. This is, again, technology meeting the business cases.
So let's talk about some of those lessons that have been learned so far in public safety HetNet deployments. What are some lessons that we can learn and use going forward?
Well, we're living through it right now with rebanding. You know, the fire department, LA Fire Department operates 18 analog conventional 800 meg channels off 9 radio sites, and when a couple carriers were transmitting close to those, we would lose radio coverage at many, many locations of the city, hundreds of locations of the city. So, and it really got to a point where it crippled our radio system because we would get an accident at a certain intersection. The fire company would call for additional resources. The dispatch center would acknowledge them, but the fire company would never hear the acknowledgement, because that cell site literally on the corner was desensing the receiver on that mobile or portable radio. So we thought our radio system was broken. We thought we had design issues, and we later found out that it was really more of a licensing and spectrum issue. So yeah, planning and planning early is really important. But I wanted to put a plug in on the commercial side, because our electronic patient care tablets that we use to take care of patients and document what's going on with them and get medical orders, that sort of thing, we do that on the commercial network right now today. There's also a tool that we started using at the beginning of the year called PulsePoint. And PulsePoint is a free app. If you're willing to do CPR, you can sign up. But our CAD system actually sends our CAD feed to about 15 or 20,000 cell phones every day in the city of Los Angeles. And so if you had a medical emergency or cardiac arrest in this hotel, but you didn't have cell coverage, but you're willing to do CPR, you'd never get the message. So we're leveraging the commercial networks to now get help in front of us. We have, in my dispatch center, we give pre-arrival instructions. We tell you how to do CPR on the phone, but we also send out a message so anyone within a quarter mile of the location can actually help, because what we're really finding is we're never going to get on scene fast enough. And so we need all the convergent help we can get. So again, this is a really good case to have a robust network, whether it's Wi-Fi or a 700 meg or whatever that system is, that HetNet system is. It's important to have it covered, especially in areas where you're going to have a high occupancy level. We have sprinklers, we have fire systems. We need that wireless coverage also for you to be able to help us.
That's great. We're crowdsourcing health. I am just encouraged. That's really cool.
Anybody else have any lessons learned from public safety deployments that you want to talk about?
None that haven't been mentioned already. Money gets involved whether you like it or not on all this technology, and then there's regulations and there's liability. These are all things that have to be worked through some way. And it sounds like the city of Los Angeles is moving in great directions to get over a lot of those humps, and they are to be applauded as far as I can tell, because that's not true all over the rest of the country.
Yeah, and Kevin, you brought up a good point in that, there are kind of two pieces to this, the public safety system that the first responders are using, but also the commercial systems do need to be robust, because if someone needs help and dials 911, they need to be able to get through to a dispatcher and to get help that they need as well.
Right. We look at a 4-minute factor, 4 minutes to hemorrhage, 4 minutes to cardiac arrest, and 4 minutes to flashover. So if you have a fire in a home or a room, and basically you get spontaneous combustion after about 4 minutes. So we know we're not going to be on scene with 106 fire stations in 465 square miles. We respond to 400,000 plus calls a year. Some we get on scene in a minute, some a little bit longer, but we know generally we're not going to be on scene in 4 minutes. So this is why all of these crowdsourcing, with our 911 system, to be able, I'm working on a project right now, to be able to locate the caller and to be able to put that on the screen for the dispatcher to verify that they're where they think they are. Because a lot of people call in an address and, hey, I'm at the Biltmore. Well, what part of the Biltmore? Well, we can actually, we'll be able to see, with a high degree of accuracy, where they are in the hotel, or they're at the convention center. Well, that's a really big place too. Beverly Hills Fire Department, some of the largest residential acreages in the county are in Beverly Hills. And just because you get on scene doesn't mean you're really at the patient or at the incident. So all these things that we can get more information about the lot, be able to push that out through broadband data. Again, that's the carrier's job for us to be able to leverage. So it's really truly a partnership. But again, the first part starts when we can get on scene and find you and be able to call for more help inside that building.
Okay. And now you talked a bit about the code that you developed. Maybe you could expand on then how that will be used going forward as you work with building owners and you work with the vendors. How will that be put to practice?
Well, what we did is, again, we got all these people together and we wanted to find what was reasonable and what was affordable, and based on a standard that we'd already worked on for the last 25, 30 years through the Red Line system. And so we developed this, it's called Fire Prevention Requirement 105. It's requestable through our website at laft.org. We're going to actually have it posted on the fire prevention website pretty soon. But what we thought was fair was to develop a standard that was very clear and understandable and gave everyone a level playing field. Now, what we were finding was the unlevel playing field was different consultants or different companies would come in and they would try to oversell. And I know salespeople would never do that, but it happened. And so we would get complaints that, hey, this guy got to put in 8 channels, I had to put in 18, this one's requiring 15. And so we realized, hey, we got a real problem. We thought that they could read the code, and we had required that they go to NFPA 72 and I-code 510, but what we found though was that it was the interpretation of that was really difficult at times. And so we wanted to help them interpret that code and put that into a requirement so they had a starting point. And I think since we've done that, we've had a lot less phone calls, a lot less confusion, and we really haven't published it yet. I mean, we've sent it out to the vendors that normally work with the city, but there hasn't been any mass, publication. Maybe we should get a set published in your magazine, And again, what we did, it wasn't rocket science. We took existing codes that were out there, and we looked to see what would fit the city of LA. So every city is going to have to decide when it has to be deployed. That's really the key, is when it has to be deployed. The standard when you deploy it, the standard's a standard. 90%, 95%, 99%. It is what it is. Testing, having competent people doing that testing for you, because what you don't want to do is spend a bunch of money, build the building, and the fire prevention inspector says, okay, prove your work, show me it works, and it doesn't work. And then that's a huge issue. So again, we want to make sure that people know what to test and how to test. And there's some really great programs out there where you can take the building blueprints. Guys like Mel can put the parameters into the system and actually show where the DAS systems need to be, the length of the cabling and the type of antennas. And so it really makes it really almost easier to design an in-building system than an out-of-building system.
Okay.
Am I allowed to ask a question?
Of course. Actually, anybody here can ask a question. Go ahead and raise your hand. I have my list of questions, but anybody else who has a question, feel free.
This one, my question's for Kevin. You've talked about new construction. I was just curious, what about old construction? I mean, if that's the right word for it.
Yeah.
But old existing buildings, is there a grandfather clause, or how does this work?
They're grandfathered, but if they replace their fire protection system, there are certain triggers that if you did a major remodel of the building, you replace the entire fire protection system, certain things like that, then you have to add that. There are a ton of pre-1933 buildings in the city. We thought that was not reasonable. But again, most of those, because they're not super heavy construction, the downside is they're kind of lightweight, unreinforced masonry that can fall on us. The downside is they're not super thick, so we can talk, simplex point to point out to the street, and they're not very deep, and we know where they are. So those may be buildings that we always use extra care to go into those buildings. So.
I think one of the points to reinforce was we took existing standards, existing recommendations, and really NFPA 72 is a recommendation until it's adopted by a jurisdiction. So we took the recommendations that basically gave you physical rules of how to install these things so that they're hardened, so that they're reliable, so that you have certain levels of redundancy. But then we went through a number of best practices. What would be the best practices? How many frequencies do we really need? What really makes sense? Talking to the radio engineers. If we put all the frequencies in it, might we have some other problems down the road? These are questions that public safety often doesn't ask, or as Kevin said, people get extremely zealous about installing things. Fortunately, LA City Fire had the experience with trying to put all the frequencies in one place at one time, and they found that they were actually crippling their own system with it. So being able to limit the number of channels creates other ways of handling this operationally. Now, every firefighter knows that any building that he goes into that has a distributed antenna system, it's going to operate on one of these 8 frequencies, just exactly like he would operate if he were in one of the MTA tunnels. So training, all of those things came in as best practices that entered into creating this policy that the city did. It was really a pleasure working with them on it.
Jim, maybe you can talk from a supplier perspective about that.
You know, what'll be interesting to see happens over the, let's say, the next 5 years, because remove public safety from a commercial viewpoint. You know, we're expecting 5G, the Internet of Things. You know, your coffee maker is going to have a Wi-Fi connection, potentially your refrigerator. You know, the carriers want the car in the garage out the bottom actually connected because it's going to be giving out diagnostics. In theory, the commercial market will have faster, better, larger coverage going on probably over the next 5 to 10 years than anything the public safety folks can bring in, just because of the business case. You know, we want to have total connectivity, so you'll be able to reach out to anything within your household, buildings, or anything else. We want this to occur. I'll say we as the market, everyone in this room, we want it to happen. And the technology that's becoming available now in terms of the massive amount of data that you can pull down from each other, I think is going to actually make their job easier. I mean, you're going to be able to potentially walk around with your iPhone watch. You can pick out everybody you want in the building, give a biometric analysis of what's happening with the guy, even before you leave the truck. I mean, that's the theory.
That's actually the future. Every firefighter who's died in the line of duty, who hasn't had something fall on them, those who have heart attacks or medical emergencies in that fire, many of them that have survived have said, you know, I didn't feel well going in, I probably should have called in sick, probably should have gone to the doctor. They end up having a severe medical emergency inside a burning building, and it creates a lot of issues for a lot of people. If we had a way for them to wear a department-approved watch, and we could see those biometrics at the command post, and gee, everybody's at a heart rate of 120, 130, 140, what's up with him? He's at 180, or he's at 40. We got a problem here. And what we found is most firefighters would rather die than be embarrassed. I'm just telling you. I've known 2 or 3 people who've been lost in buildings who flat out, when they came out, they said, yep, rather would have died than admit to my buddies I was lost. And they would rather die than admit that they're having a medical emergency. And it's just the way we're wired. It's just the type A personality. So we look at this kind of connectivity, and again, if we can get connectivity inside of a building, you know, again, voice communications, simplex operation, most important. But if I get all those biometrics and I can actually see, like Mission Impossible, all that cool stuff that really doesn't exist yet, but we can see where firefighters really are, I may not have to go in and rescue somebody. I may simply have to just tell them how to get back to a hose line. If I can see the coupling, I can see the nozzle, I see that person wandering away, and I can tell them, hey, make a 180, keep going, stay right there. The Worcester fire lost, 6 firefighters on that in Massachusetts. They lost 3 firefighters. They lost 3 more going in to rescue the 3 that died. They were 1 wall apart. So when we ask about accuracy, location accuracy, 1 foot is what we need. So those are all the things that we can leverage, you know, that are going to help us in the long run, and we definitely want to support those efforts.
Yeah, questions from out there? I'm very curious.
Commercial DAS system usually serves multiple bands, 5, 6, 7 bands, multiple remote sources, multiple base stations. It could serve additional band that would be allocated to 1 or 2 bands for public safety, and get it from the sources that are like the sense out from the next field, etc. What would it take for a DAS to do that you would accept the DAS as a tool?
So the question, just to repeat so everybody can hear, what needs to happen for a dual DAS system for public safety and commercial networks?
What are the requirements that the DAS has to meet in order for it to be recognized as a DAS that can be a dual-purpose DAS?
Well, in Los Angeles, we left that part of the code open because we're not going to say that you have to have a public safety only DAS and a commercial DAS. So as long as the DAS that's installed meets all the NFPA and ICODE requirements, and if it also happens to serve the commercial community too, and they don't interfere, that's great. So there's no requirement. Matter of fact, I think the real, I'm not an engineer, but I think the real expense is running the cable and the antennas. What you kind of hang on that is expensive, but not as expensive as the labor to run it like cable. So once you have that highway kind of designed and the antenna system designed, you know, I think you can put multiple amplification systems on there. So
The goal, is just what the chief said, the goal in regards to this overall is to build a DAS system that at least meets the requirements of public safety. But in addition to that, public safety looks like another operator. I mean, behind it, you plug in AT&T, you plug in T-Mobile, you plug in whoever. Behind there going through it, and you can handle whatever bands are in place as long as you build it out ahead of time. The architecture isn't that difficult to figure out. It's being done today with multiple carriers. Even though, yes, there are some issues with public safety in regards to survivability, we'll say that I think the technical requirements from the carriers is actually a little bit more intense, just because we're dealing with frequency ranges, the entire band going through it. So the goal would be to have them similar, to have a DAS system that one can be put in place for public safety, and you can add the other carriers along for either revenue sources or amenities for the building.
Can you add public safety to a commercial carrier DAS that's already there? Or does it have to?
Well, again, the goal would be yes. Again, whatever requirements are in place. Do you need backup power? What kind of systems you want to put in place? What kind of survivability? But these are addressable. I mean, these are market driven. Again, we're talking Los Angeles here. Other states, counties within the United States are a little different.
Right.
Going across. But the goal would be either have existing DAS that you can fill public safety into it, or you're going to build up public safety due to requirements, knowing that it's not essentially a sunk cost, that you could add to it in terms of being the building owner, use it as an amenity, et cetera.
The problem is probably much more policy than it is technical. It's kind of the bottom line. Carriers don't want, in a lot of cases, and once again, it depends on which carrier and which engineer you're talking to, they don't want other people to have access to, quote, their hardware. They're worried that it puts their hardware at risk. Public safety in a lot of jurisdictions doesn't want anyone touching a life safety system because it may put their system at risk. So if you can work out those details with responsibility, having to do with responsibility and the personal logistics or the individual logistics of how you go about managing those systems, I don't see where there's any reason you can't do that. Keep in mind, though, that public safety operates in little slivers of spectrum running from about 150 megahertz all the way to 900. So it's not like cellular where you have large blocks of spectrum and you can count on these large blocks. Instead, it can be very, very trying to try and get their frequencies into a DAS system. That's one of those that I would go back, if I were in public safety, I would go back to the manufacturers and I would say, does it make more sense for me to have two independent DAS systems in a building from an interference standpoint and a management standpoint, or does it make more sense to have one and then work out the policy differences?
Any preference when it comes to cabling infrastructure, for instance, fiber optic versus coaxial cables, or it doesn't matter?
Chief?
It doesn't really matter. We have both in the city. We look at survivability and fire, and we're not going to be at a building that's on fire for 2 hours. I should say it's pretty rare. The Federal Reserve Bank fire, it was an old Federal Reserve building downtown that burned for a couple hours. I was on the library fire, that burned for quite a while. But generally, if we don't get a knockdown in 20 to 30 minutes, we're not going to keep people inside. We're going to go into defensive mode and go outside. So the fiber optic part, if you have that in conduit based on the code, is it a